is Boris. I'm data scientist working at Exness in the marketing domain. And today I'm going to tell you about geo-testing in marketing. And basically, it's supposed that you don't know much about geo-testing, but it also could be insightful for advanced analysts. And so for my presentation, I will make an intro. What is geo-test? When you will need them, why we need them, and how to conduct such test, but without a lot of technicalities. It then also suppose you in some context of marketing. And just before we move to the main topic, I just want to share with you what is my context. I work in marketing in Exness, and actually in Exness we have a lot of countries covered by our operations, and lots of ad platforms such as well-known Facebook, YouTube, TikTok, and actually much more. And of course, a lot of investments how to cope with all that. So our answer is we use data-driven approach. Actually, the main goal of marketing, as we understand it, is to track and improve some efficiency of budget, marketing budget spending. And what you need to do this, first, of course, you need to collect data from tracking data from ads platforms, and a lot of work is done around this. And actually, one of the main questions is how to attribute your spendings to some good things. You call it target metric, and this is called attribution. So we build in our a lot of questions about these attributions, and also we need somehow to present our results. For this we need dashboards. So, and we need this to understand what is the actual measure, what is the actual target, and for in the context of markets, maybe some of you know this term. It's called ROAS, ROAS, return on ad spending. So, and of course, we conduct a lot of A/B tests to infer what is the influence of our spendings, of our investments to this metric called ROAS. You may ask just why you need this. What is geo-test? Why, when you need them? And basically, what is test? Test is when you do something, you observe some changes, and you want to understand what is this change, how to split your changes, like to pass like changes is caused by your treatment, by your action, and some other factors which you do not control. And to help with this, you have a golden standard technology called A/B tests, randomized A/B tests. But for do it, you need ability to randomize to control these unobservable factors. So, what you could you do if you cannot afford to do this randomization, and you actually have a lot of situations? And in our context, actually, my presentation is based on recent tests we conduct in our company. We already have like established mix of performance campaigns, and we wanted to add some more campaigns called brand awareness to broaden the knowledge of our brand. We have a complication. In this case, we can just choose some clients and split them randomly, because we have not access to the data about these clients. This data is actually collected by ad platforms, and they don't want to share them. And if we could effort, for example, is for some platforms to conduct A/B tests for us, but our treatment is the mix of ad platforms, and if we may think of conducting the A/B test with just one platform, if you have like a lot of platforms, they can't share the information about clients between them. So you cannot guarantee that there will be no intersection between control and test groups. So this is complications, and so we need something to do, and the answer is geo-tests. So the main idea of geo-tests is, instead of taking your clients, make some randomized split, you take regions, cities, which is called geos. So you have like a bunch of geos. It could be cities, it could be regions. Like you may have, for example, take some country, Vietnam, you have like a handful of regions are actually captured by the dynamics of these like seasonal factors, actually captured these peaks and downs, like they captured by control geo, some other geos. So if you take this difference after you conducted the test, you see that they were correlated before test. They have roughly the same distance. So you may like think that if you have no treatment, you would observe these correlated dynamics even further at the test period. So you plot this, like you have like such plots, and you may see in this picture, for example, that of course here is the fact is that this difference of observable dynamics and so-called counterfactual dynamics, which could be if you have no treatment. So you also have other complications. Actually, this correlation is not precise, it's not 100%, and there may be some other factor which is not captured by the control. And how to cope with it? The answer will be in latest. I will cover in latest talk. So, what is the pipeline of geo-testing is pretty simple. It's similar to usual like design of conducting of A/B test pipeline. So you have pre-analysis phase, you have test phase. When you run your test, look for your metrics, make some sanity checks if needed, and you also have you stop your test for predefined period, after predefined period, and you after this you need to make estimation what was the effect. So looks pretty standard, but where is the complication? Complication is the first phase, actually pre-analysis. And yeah, in this slide you may see this the only memory in my presentations is because this the central part of my presentation. These technical complications, technical tricks which you should involve in your this tricky part called pretest is this one. First, you need to choose your procedure for estimate your effect. It could be easy, like I showed you, like you may just subtract control from test, but actually its procedure have its own drawbacks, so we'll talk about later. This is like 3 pillars to successful a geo-test design, specific to geo-test. Second is one, choose you need somehow to split your geos, which geos to take as control, which geos to take as test. And also you need to estimate so-called placebo effects. And if you don't know what's placebo effects, of course, I will explain you a little bit later. Placebo effects are actually this unobservable part which don't capture it by control. As regarding to geo-split, how to do this, actually you may already guess that the best split is which gives you best correlation across control and test split. And if you have a bunch of geos, you have a bunch of possible sets. You may split which one to choose. You may do this with a lot of tools. We use special tools designed for this task. It's developed in Google called Matched Markets, and actually this tool, like using some greedy algorithm, make it for you, and it proposes you to test and which geos you should test for. Take for control, which geos you should take for test. So it's best. You have best correlation. This picture you see this picture on the right. It shows you that actually you may find such geos. It's a real case. You find such geos which very highly correlated, and actually it's also. I promised you with some to provide you with some tweaks. Of course, you it's recommended to plot to show how these regions actually distributed across the map, and you may do it with Google Maps to see how it looks. It's better if they distributed randomly, like as it's shown in this picture. The second pillar, second step is to choose procedure for estimating your effect. Actually, there are plenty of options here, and I will cover three of them. They are listed in my slide. The first is well-known difference in difference techniques. And actually, half of my goal here, and if you will understand this, what is difference in difference, if you're not here, my mission will be achieved. Difference in difference, very popular and powerful technique, but it has its own drawbacks. So we have another option. Two-way fixed is called two-way fixed effects. Is the extension of difference in difference to panel data. We have synthetic control technique, and you have other more complicated techniques which try to combine the benefits of previous ones with synthetic difference in difference. But here I want to stop. I'm not going to go deeper into this. I just recommend you, if you will interested in some tricks, some technicalities of these complicated models, I recommend you to web resource called Casual Inference for Brave and True. Actually, these presentations also will be shared after my speak, so you may find it with names later and research by yourself. But what should you actually need to keep in mind when you choose which procedure is better is that each procedure gives you different result, different estimations. But these results, as I said, have some error called placebo effects, and you actually third pillar would be you estimate your placebo effect, and you may choose the procedure which gives you less error, as simply as this, and also you should keep in mind that it's not obvious what you should prefer most complicated model. You may because maybe you've heard about this. This exists some so-called variance bias trade-off in data science, this concept of variance bias. So if you will choose oversimplified model, you will have high errors, and if you have biases. But if you choose over complicated model, you will have low bias but huge variance. It's also bad for error. So you need something in between, and we actually used the second method, two-way fixed control, because it's appeared to be like most balanced in terms of this trade-off. And so I will quickly run through three methods which was mentioned in first slide. First one is well-known difference in difference. And this is the most simple and the most heavily used in practice in most famous causal inference methods. It's so famous that authors of these methods were awarded with Nobel Prize in economics in 2021. What is it? It's very intuitive. You just take two differences. One is the difference of your treatment before, after treatment, and before. It's shown on the right picture here. The average level of your metric before treatment, average level of after treatment, and for example, we see here white line is the control, yellow line is test. So we see that control is actually increased, and test is actually decreased. So what you observe in real life, you see this decrease. You may conclude that yes, something bad happened. The metric is decreased, but actually it's more bad than that, because in the same time control is increased. So your actual change is much lower when you observe. So the formula is very simple. Is shown here. The second line. You just calculate the change of your treatment and control for control groups by subtracting the change in control group. So it's also could be reformulated in terms of like regression model. So, but we will not cover it. Let's move on to the methods we actually used, as I said, is two-way fixed effect, because in our case we actually have so-called panel data, and this two-way fixed effect is the extension of simple difference in difference meant to the panel data. What is panel data? Panel data is when you have multiple of items, not just one treatment and control, but multiple treatment, multiple control, as in our case, multiple geos, and multiple time points. Not only before and after, but many days, say, or weeks. So difference naturally extends to this case. This is the same formula, but for here the coefficients you trying to find with your model is there are more of them, but actually you may do it with your any like the Python package for linear regression. But this method is not without its own drawbacks, and as difference in difference, the main drawback of these two methods is it supports that trends, which followed by your metric parallel. So if they are parallel, they maintain this difference, and you may subtract it. But what if initially they have different trends? For example, your treatment is increasing much faster than control, so this method doesn't capture this effect. So there are also some also famous methods called synthetic control. Synthetic control is called this self-explanatory name. What you do is actually reconstruct your treatment with control geos like weighted sum, just weighted sum of your curves, and you use this in test period. You just plot this weighted sum of control on the test period, and this is supposed that it's how your treatment would behave without treatment. So you have like this synthetic control curve on the right. You have actual curve, and you just subtract one from each other and summing up with your effect. Actually, it's very close, but I'm not going into deep technicalities. So you have many possible procedures which you may use to estimate your effect, but most intricate thing is placebo effect. What is placebo effect? You may, of course, know that in medicine, placebo effect is when you have a pill without actual medical substance, and you give it, and you observe some effect. And here it's not the same. Here is the absence of pill. And placebo effect, this is effect which you could observe even when you know for sure that there's no effect of treatment, because there are no treatment was made. Actually, there are two approaches to estimate. So why you need this placebo effect? So this placebo effect is your error of your estimation. You make your estimation. You say, for example, 10% increase. So what is causal inference all about is you need to provide some confidence level around your estimation. And you actually need to say something. Yes, my effect is between 5 to 15%. And what are these bounds of confidence? This bounds is determined by your placebo effect. Because, for example, if your estimations is, you say, 5%, but placebo effect also could be like plus minus 5%. So you may conclude that your 5% may be merely just by this placebo effect, not by your treatment. So you need somehow to estimate it. There are two approaches. One is theoretical. You may just research how this models parameters behave, like in the statistical process. But more robust, as we discovered in our case, there exist more robust methods. You just you may use so-called bootstrapping simulations based on your history. So the procedure is exactly like shown here. We do these simulations. The scheme is in the above picture. You have your timeline. You have somewhere your hypothetical tests are. So you just take moderately long period before your test, where you expect no much structural changes, but long enough to sample from to your estimations could be statistically significant. And you sample this, you hypothesize that your start is somewhere in the past. You run your procedure, you estimate your effect. You know that there is no effect, but you get some effect, and so you conclude this effect X is placebo effect. So it could be X. What you conclude? You make you take another point, you get Y. So you conclude it could be Y. So you sample these different errors you could get. So and you arrive to distribution of your placebo effect, and you also may plot your placebo effect with X along the timeline, and you observe that it like behave like some smooth curve. Yes, and this is a bit complicated thing. This it doesn't look like white noise. So it's maybe you may guess that maybe this distribution is actually not much correct because it's not these observations of placebo effect in history. They are not independent. They are so-called autocorrelated with each two close time points. They are like close. So, but yes, you maybe this precision not so precise. But if you're, for example, sampling actual test start is a bit distanced from the the end of this period. So this autocorrelation story is like disappears and actually doesn't affect much your estimation at the test time. This is the simple solution we arrived to in our case. So basically, this is all. And what about business value? You may ask. Yeah. I mentioned that the most problems are focused on assessing this effectiveness of marketing spends, and these assessments need somehow influence your business decisions, and which decisions you may like, look, this company doesn't work, or this company works, even if other metrics show you it is not. For example, the information you could get from your ad platforms may show you, yes, many visitors came last month, but no effect. You measure with your uplift, you get effect, no effect. So the business value is you just simple as this. You keep running effective campaigns or stop ineffective, and you get like more optimized budget spending. And also, so market, you also may try to do something more complicated, more reliable, and which involve all the factors which may, for example, give you ability to predict something and predict your possible effect. Because when you're testing, you're just testing the exact setting. Just you have this marketing mix, you add something, you test it. But if you imagine if you have a model, you may plug into the possible scenarios, and this model will give you what would be outcomes. And this is actually a more complicated thing in the context of marketing spends, marketing mix optimization. It's called marketing mix model, and actually we are working on this wonderful thing, and hopefully may share our findings in next meetup. So stay tuned. Stay tuned. And short takeaway. is very simple. Whenever you can use A/B testing, use it. It's most accurate method, but it requires some. You can manage, and you can your audience, and you can split it randomly. If you could not, you may use geo-test. Cheer up, use geo-test. It's less accurate, but it's better than nothing. Actually, it's good thing. That's all.
You make this for all platforms together, or you split it by each platform when you run top campaign, for example, Instagram, Twitter? You split it or?
No, we choose some mix of channels.
Campaign for.
Yes, we design very forcefully our campaigns. We see what campaigns should work in which countries this works, this works, and it depends also is it established market or not established, what is could be the brand awareness. So we design carefully for each country this media mix, like which we want to test and test it by using these geo-tests.
Okay, I have a couple of questions we discussed.
Yeah, we discussed this privately.
Hello, thanks a lot for your speech. Very great. Actually, I have a question. How big geos do you usually take for your tests, and how many of them do you put in one split? So there was a picture and there were like 20 dots for one split. So why I'm asking, the question is about usually using geo-testing, we can confront some events in region, like for example, weather change or some political situation. And if this happens only in one region, for example, in control, not in treatment, control can behave unpredictable, and usually it damages all the tests. So how do you handle this?
Actually, very, very good question. Some of countries we have very, very big regions, very big geos, which determines the whole control group, so it influences too much. And in this case, you may split it further. For example, if you take, basically, my advice is start with regions and split it to lower level, like cities. If you have some complications, you see them in history. And actually, this why not good to make as a start a lot of geos, because a lot of noise, a lot of parameters need to be estimated, so model becomes overcomplicated.
Hi, thank you for your speech. I have a question about modeling of placebo effect. On the plots you showed us, it looks like a placebo, it looks like a random walk. So haven't you tried to model it not as it is, but maybe, for example, model the difference of placebo effect with its own value on previous period? So maybe distribution will be a bit better and you can...
Yeah. It's very close to you asking about why you don't try to model this the behavior of this.
Yeah, kind of model it, or maybe model
you actually can model it.
Yeah, but I mean not just a placebo effect, but maybe a difference of placebo effect with itself.
As I understand your question, you won't be sure that this placebo effect actually have centered around zero, don't have strengths, and if you imagine that placebo effect could have strength, so yeah, your estimations will be incorrect, because for it work, it should be the mean should be around zero. So if you take this difference and you see that this difference is distributed not around zero, so you conclude that the placebo effect have sort of trend, and this is could be the problem. Actually, it is. In our cases, we saw such cases with some procedures, with some geo-split. You see that your placebo effect actually have bias. It's not around zero, and so you may think and choose another procedure which gives you the better picture, which with placebo effect actually centered around zero.
All right, thank you. I'd like to discuss it with you a bit more later.
Okay.
Thank you a lot.
In a classic A/B test, there is only one option for user. It can be in treatment group or in control group. But if we are talking about splitting users by geo-clusters, I can just move from one region to another one. And how you check this bias and how you make sure that user only in one group, in one geo-cluster?
Actually, we don't control by this. We just assume that they can move one or other side, and they do it like proportionally.
Thank you for the presentation. My question is, if we want to control multiple metrics during our test, if we want to estimate effect on multiple metrics, how do we perform our splits?
We actually also saw we met this situation when we choose our main metric like conversions, conversion rate. But as you know, marketing is complicated. You have like this different points of conversions, and you may want to able to answer questions what happened with other metrics. Actually, this what we saw that you actually design your test, make a design which is fitted for just one metric, and you also may use this procedure to estimate other metrics, but the placebo effect will be different. It usually will have like more wide confidence intervals, like it will be widespread. So your estimations of other metrics, you could achieve them, but they will be not will be a little bit less reliable with much little bit higher confidence intervals.
What is a mistake that a beginner can make and lead him to wrong results or in a wrong path?
As I was trying to show you, you have like a lot of instruments. You should need care of a lot of things, and the main point was each like design gives you different estimates. So you need just to first I recommend you to benchmark your, for example, estimations with sophisticated model with very like no-brainer estimations, like is difference in difference. And if it behave like you have like positive effect with sophisticated, high positive effect, and negative effect with difference, you should think twice. Always try simple things.
Okay, I see. Thank you.
Imagine if you want to run several campaigns in one geo using geo-test, how you're measuring that user is not influenced by several campaigns, or how you're separating these effects of different campaigns?
Actually, I don't know, because we here, what I've discussed, we don't separate effects. We couldn't separate them. Because to separate these effects, you should to benchmark this to some data for historical, and if you have no such data, you have not points to compare. So it's for this task is more suited what I mentioned, marketing mix model.
Okay, good.
Yeah.
Thank you.